Click on the subscribe button to stay updated on awesome tech gyan. Also, click on the bell icon to ensure that you are always updated whenever a new video is posted on this channel.
Hello friends, my name is Souvik and you're watching Souvik Says, the channel that helps you decipher technology. Now in today's world, a major decision point while you're buying a portable device, be it a mobile phone, a tablet, a smartwatch or even a gaming console, and yes, I mean the Nintendo Switch, is the battery life. I really wonder if we understand how exactly does the battery work, what are the nitty-gritties of the battery, how does it store energy, how does it release energy, and how does it subsequently charge. We're going to look at that in this video, so stay tuned. In today's video, we're going to discuss the following. Number 1. How does the battery store and discharge electricity? Number 2. What is the process of charging a battery? Number 3. Understanding the battery charges better. And number 4. Looking at some prevalent charging terminologies. So how does a battery store and discharge the electricity? Well, a battery consists of two electrodes that are separated by some distance. The space between these two electrodes is filled with something called an electrolyte, which is a liquid that conducts the electricity. One of the electrodes is called the anode, which permits the electrons to flow out of it, and the other one is the cathode, which receives them. Now, when a connection between the anode and the cathode is made, the electrical path that is provided by the electrolyte and the external electrical circuit, it results in the electrons being freed from the anode, which travel through the external circuit and react chemically at the cathode. Due to the travel of the electrons from the anode to the cathode, it results in the discharge of electrical energy. Using this mechanism, the battery can continue to discharge until either or both of the electrodes run out of the electrons, thereby making the battery dead. Let us now understand how does the battery recharge. Once the battery is completely discharged or dead, to recharge it, an external source of electrical current is required, which supplies the electrons back to the anode and removes them from the cathode. Typically, this is the reverse chemical reaction to how the battery discharges. So this chemical reaction continues till all the electrons are back to the anode. Next up, let us understand our chargers better. As I spoke about in the previous section, a charger is a device that reverses the process of discharging by supplying electrons to the anode and removing them from the cathode. But what about the various ratings we see on our chargers? What does a 5 volts 2 ampere mean, and how is it different from a 5 volt 1 ampere? Well, charging power is based on three things primarily. The power, which is measured in watts, the current, which is measured in amperes or milliamperes, and the voltage, which is measured in volts. To make it easier, let us now compare say a USB 2.0 port on my laptop and the charger that came with my phone, which is the OnePlus One. Now the USB 2.0 delivers 5 volts and 0.5 amperes or 2.5 watts of power, whereas the OnePlus One charger delivers 5 volts and 2 amperes, which is 10 watts of power. Therefore, if I charge my phone through the USB drive, it will take 4 times longer to charge it as opposed to using the charger that came with my phone. And don't worry, if you plug in your tablet charger into your phone, it's not going to burst into flames, because devices nowadays come with inbuilt power management chips. What these chips does is it helps regulate the amount of power that's going into the battery, and will only draw as much as is needed for the battery to charge efficiently. So whenever you buy a new charger, make sure that it's rated appropriately according to the device that you are planning to charge, and that you'll be able to charge your device sufficiently well with it. And please avoid buying cheap stuff from the roadside or your friendly neighborhood hawker. Charging terminologies: quick charge, fast charge, turbocharge, dash charge, black charge. Well, these are all terms that point towards just one thing, which is pushing out more power to your device, thereby resulting in the battery getting the initial charge quicker. Now, note the use of the word initial charge. This is because all these technologies use the Qualcomm quick charge methodology in order to deliver more power to your batteries. What this technology does is it charges your phone rapidly to a predetermined level, which is typically between 60 to 70%. After the battery reaches this threshold, it will turn to a more conventional charge or a trickle charge, where it will be charging exactly how a normal battery charges. This is why you would see almost every advertisement that talks about quick charge will talk about the time it takes for the battery to go from 0% to one full day of use, which typically is 50 to 60%, and depending on the brand it takes maybe 15 minutes, 30 minutes or 40 minutes in order to reach that threshold. A very important point to note is that quick charging isn't just dependent on the charger that you're using, but also on whether the chip in your phone or the SoC in your phone supports quick charge, and most importantly, whether your device manufacturer or your OEM has actually paid Qualcomm to make that feature available in the device. So please go ahead, do your research before you go plunging for that fancy quick charging power brick, because that's not going to do you any good. Alright friends, that should be it. If you liked this video, give it a big thumbs up. If you didn't, vote it down. And please do consider subscribing. You can also connect with us through Facebook, Twitter and Google+. Links to them provided in the description below, so do check it out. You guys have a good time, and I'll see you in the next one. Bye-bye.